So let's just start off with a recap of what we've talked about in the previous week. We were talking about models, right? The different regression models we're going to look at in the course, and saying that we can break them into one of two broad goals: predictive models or effect size models. Right? So we said there, predictive model, the focus really is on this outcome, trying to get a good prediction or estimate of what is that outcome. An effect size model is focusing on what are the coefficients in the model, where there we're trying to say, what effect does x1 have on the outcome? B1 being the variable that captures the effect of x1 on the outcome. So to give an example, let's think of an outcome variable of, say, I don't know, salary. Okay? A predictive model might be looking at what variables do we need to try and predict what someone's salary is. Right? So what are good predictors of those? Knowing the industry they work in, years of experience, biological sex, right, or age, things like those might be good predictors. So there, the goal is trying to predict that outcome and thinking about what variables are good at predicting that outcome. An effect size model might be asking questions like, say, what effect does having a graduate degree have on your salary? Does it tend to increase it or not? And if so, on average, how much does it increase it by? Right? And then we're thinking of what variables are associated with both salary and having a graduate degree, right? The idea of confounders, which we'll expand on, and adjusting for those. So we talked about, in an effect size model, at B1, right, the estimated effect that x1 has on the outcome is beta 1 plus some error plus some bias. And again, let me add in the words for the notation here. Our estimated effect, what's the estimate of the effect that x1 has on y from our sample, is going to be equal to the true effect. The estimate we get is the true value, plus some error, right, or some noise, you can think of it. It's because we have a sample, right, we don't have data for the entire population, there's going to be some error in there, plus some bias. We said this bias is due to confounding or other factors that we'll get into. And we talked a bit about the idea of how we can try and decrease that bias. And one of our focuses in the course is going to be on statistical adjustment. So, including other variables, deciding which variables do we need to adjust for. Now this will give us what effect does x1 have on the outcome, adjusted or controlling for these other factors. Okay, so we talked a bit about this idea that a lot of our course is going to be focusing on the idea of estimating effect size and trying to adjust for bias. Previously, we recapped the idea of simple linear regression. So thinking about when our outcome variable is numeric, and we have just one x variable. So this idea of here's x1, here's y. Fitting some line, there's some regression model to that. And we reminded ourselves of all the ideas of the slope, the intercept, what their interpretation are, r squared, the way the model is selected, trying to minimize sum of squared errors, all these sorts of things, right? So in general, what are the main ideas? We talked about the assumptions, the model as well. So the goal there was to remind ourselves, what is a regression model? What are the components of it, and so on. In a moment, we're going to start to talk about multiple linear regression. So building on this idea, but I think the first thing I wanted to say was the way we're going to approach the course is first we're going to talk about a lot of different concepts sort of compartmentalized. And then once we get through that, these little compartments, we're going to start to tie them together. So we talk about simple linear regression. I'm going to talk about what does multiple linear regression look like when we have just two variables, when one's categorical and one's numeric, or when they're both numeric. We're going to talk about the idea of what is confounding, again, in its own compartment. Just the concept of confounding ignoring the model and other variables and so on. Then we're going to go into compartment, what's effect modification or interaction? And again, looking at that just on its own. And then once we've gone through all these different components, and I think around week 4 or so of the course, once we've talked about all these ideas, we're going to tie them all together and try and build a model to estimate the effect of some variable on the outcome, adjusting for all these other confounders, including effect modifiers and things like these, putting all these ideas that we explore individually together and tying them back to the big picture. So let's get into multiple linear regression.
Stick around, guys. There's more to see, and please stay safe.